Okay, let's talk about limits and equations. Okay, so we've got this equation right here. Let's say we want to determine the limit of this function. So of this function, we want to find the limit as x approaches 2. So we don't have a graph to look at, so we can't like trace a line. So we want to take this and we want to find the limit as x approaches 2. Okay, so I'm just going to show you this as a table first. So if I think about a graph approaching 2, I think, okay, well I'm going to try to find what's x equals 1, what's x equals 1.5, maybe like 1.9, and then what happens at 2. So I'm going to kind of approach it from the left, like a left-hand limit. So when x equals 1, y would equal 1 squared minus 1, so 0. When x equals 0.5, when x equals 1.5, 1.5 squared minus 1 would equal 1.25. And then if I sub 1.9 in, okay, I need a calculator, 1.9 squared minus 1, 2.61. 2.61. Okay, oh, maybe I want to try even closer. So what if I want to try like 1.99? Let's see what it is. 1.99 squared minus 1, 2.96. 2.96. Okay, cool. So I can see as I get closer and closer and closer to 2, I'm just subbing my values in here. So I subbed in 1, 1.5, 1.9, 1.99. I'm just seeing what happens as it gets close to 2. Let's check out what happens right at 2. When x equals 2, 2 squared is 4, 4 minus 1 is 3. So that's cool. I could also come at it from the right. So I could say, I could start over here at x equals 3 and then start coming, closer and closer to 2. I'm just going to skip some because I don't want to do 100 calculations. So if I try like 2.1 or 2.001, so I'm looking for numbers that are really close to 2. And I sub those in, so 3 squared 9 minus 1 is 8. 2.1 squared minus 1, 3.4, 0.41, and then 2.001 squared minus 1 equals 3.004. 0.004. So if you look at these values, 1, 2, 2.9, 8, 3.4, 3.004, they're all approaching 3. So the limit of this function as x approaches 2 is equal to 3. And I mean, we could have just subbed in 2 and see what we get. But it's interesting, like it's important to see that as we approach it from the left or the right, it's the same value. And we actually knew that because we know this function is continuous. I already know that's a parabola, and I know parabolas are continuous. I know this graph looks exactly like this. So it totally makes sense that the left hand and the right hand limit would be the same. So since I know it's a continuous graph, I would know that that's where my limit is approaching anyways. Okay. Let's look at a more complicated equation. Okay, so let's look at y equals, you know what, let's write this using a limit notation too. So let's find the limit as x approaches 1 of x squared minus 1 over x minus 1. So we've got this. So we're trying to figure out, as this function approaches 1, what is the limit? So you could do this again using a table if you want, which you will for 2 seconds, and then you're going to do it a different way. So if we just looked at it with a table, we know it's approaching 1. So say we want x to actually be 1. So we pick values up to the left and right that are close to 1. So I could pick like 0.999 I'll just pick 0.9. I'm just going to pick really close values. So 1.001, 1.1 maybe. Okay, so I've picked those values. So now I'm just going to see what their y values equal when I sub that in. So right away I know if I start in the middle here, if I sub a 1 in, 1 minus 1 is going to be 0 in the denominator, which is going to be undefined. So that's actually not helpful. So just subbing it in this example, that didn't even help us figure out the answer. Okay, so on the, sorry, I should have done this ahead of time. I'll just pause it. Okay, I paused it and I got all the answers. Okay, so hopefully I didn't make any mistakes. I got 1.9 for this when I subbed in 0.9. When I subbed in 0.999, I got 1.999. And on this side, I got 2.001 and 2.1. So which value does it look like it's approaching? To me, since you got really close to 2 and really close to 2, it looks like you are approaching 2. So I would say the answer to this question is 2. We're approaching 2. And this was one where we couldn't just sub in the number 1 because it just was undefined. So we know that the graph is approaching that. Another way to solve this question would be to use like a strategy like factoring. So we're going to get into that in class. But the question was this. So we want to be able to just use substitution to find out what our limit is equal to. But if we can't just sub it in because it will be undefined, we need to just manipulate the equation to try to make it not have this in the denominator. So I'm going to use good old factoring as a strategy to simplify this equation. So I notice that the top is a difference of squares, so I can factor it into x minus 1, x plus 1 over x minus 1. And then I can actually cancel these out. So I'm left with just x plus 1. So at this point, I can just use straight substitution. 1 plus 1 equals 2. So I just found that the limit as x approaches 1 for this function is 2 without having to use a table of values. So sometimes you have to manipulate the equation so that you're able to just sub in those values. Okay, there's another crazy strategy that comes up a bunch that you're going to struggle with. So let's try this. So we want to evaluate the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. So here we run into a problem. Like we don't want to set up a table of values every time. That's super time consuming. But if we were to use straight substitution, we'd have a 0 in the denominator, which is not good. So we need to simplify this. I don't see any way we can factor this. Well, we kind of can. So remember trig identities? This was kind of like a trig identity strategy. It's kind of called like rationalizing the numerator. So or we're kind of turning it into a difference of squares. So we're actually going to multiply the top and bottom of this equation by root x plus 1 plus 1. And we can't just multiply the top, so we have to multiply the bottom by root x plus 1 plus 1. So this is crazy, especially if you forget factoring. But here's what I'm doing. I'm noticing that I kind of have a situation like this. I've got an A, I'm calling this A, minus B. So I'm just generalizing, like there's a term minus a term, A minus B. So I know, because I'm really good at factoring, that if I just stick an A plus B beside it, so I stick an A plus B, so notice it's like A minus B, so I'm just saying A as in some random group of crap minus something. And then if I do the same thing but do a plus sign, I know that that's a difference of squares. So I know that's going to equal a squared minus b squared. So for example, I know x minus 1, x plus 1 is actually x squared minus 1 squared, which is 1. So like just knowing a difference of squares will do that. This is an excellent strategy. So I'm multiplying mine by, it's like rationalizing the denominator or numerator. So I'm multiplying it by kind of the same terms but opposite sign. So now I know that when I multiply my numerator, I'm going to get a squared minus b squared. So I'm going to get root x plus 1 squared minus 1 squared over a whole bunch of junk on the bottom. So x times x plus 1 plus 1. So now I'm just going to go through and simplify stuff just using algebra skills. So x plus 1 squared, well, handy. My square root and my square are opposite operations, so they cancel out. So all I'm left with is x plus 1. 1 squared is just 1, so x plus 1 minus 1. Over, I'm not going to expand the bottom because something cool is going to happen. So there's the bottom. So I know plus 1 minus 1, guess what? That's 0, so that's going to go away. So now I'm noticing I've got an x in the numerator and an x in the denominator. Those are going to cancel out. So that's awesome. So since those canceled out, technically there's still a 1 on top because really we just divided them by x. So there's a 1 on top, and on the bottom I've got root x plus 1 plus 1. Can't cancel out the 1s because there's this addition sign here between these two terms. But now I can go ahead and sub in, use substitution, like sub in 0 for my x. So I'm going to lose the limit thing and just go ahead and sub 0 in for x and solve that. So 0 plus 1 is 1, root 1 is 1, 1 plus 1 is 2, so my answer is 1 over 2. So now I know in that giant equation up here, wherever that question was, up here, the limit as x approaches 0 of this function, that function is approaching a half. So I had to use a strategy to manipulate the equation. And sometimes you don't have to use any strategy. Like in that question we did before, like x minus 1. If you wanted to find, you know, the limit as x approaches 0, you just sub it in, because that's fine. 0 squared is 0, minus 1 equals negative 1. Done. But sometimes you might have to do a strategy like factoring or rationalizing. That's what I was just calling that last example. So you might have to like do something. And usually those are the main two strategies that we use.